2025 A-Level Combined Mathematics Paper 2 Part B, question number 14, Part A. Part B of the same question will be discussed in a future video, link in the top right. Part A of this question has to do with vectors and vector geometry. The question says, in the usual notation, let A vector be equal to minus I vector plus j vector and B vector be equal to I vector plus 2j vector be the position vectors of 2 points A and B respectively with respect to the origin O. It also says, let C be the point such that OC vector is equal to OB vector, and also let D be the point such that DC is parallel to AB and AD is perpendicular to AB. Given this, we are asked to show that OD vector is equal to minus 8205I plus 1105J, and then given that E is the point of intersection of AD, AB and OD rather, show that AE vector is 1/10 of AB vector. Now, to start off this kind of question, probably the best way that you would start is to draw out a diagram containing all of the points and vectors, which you could then use to draw relationships and eventually make equations that you can use in order to solve the question. So what we're going to do is do that. We're going to go down here to this diagram and we're going to start drawing the vectors. Now let's assume that the I vector is in this direction, it's the unit vector in this direction, and the j vector is the unit vector in the perpendicular direction of this direction. Now given that the vector A, which is minus I plus j, which is corresponding to the point A, given this is the origin, would be somewhere over here. So the point is somewhere over here, this point is A, and therefore the vector OA would be this vector, which is something like this. And the point here at the end of the vector would be point A. So the vector here is the A vector, and the point at the end of it is the point A. Now after that, the B vector is I plus 2j, which would mean it's somewhere over here, and also we know that OC vector is double of OB vector, and due to this, if the position vector of B as in OB vector is I plus 2j, then OC vector is going to be 2I plus 4j, which is going to be collinear with that first vector but twice as far away. So due to that, if we draw the vector, draw a line like this and call this point over here B, then at a distance double that of OB, we're going to have another point here, which is going to be the point C, and the vector OB is going to be the vector B vector, and this vector is also going to be B vector, since we have double B vector being equal to OC vector, and due to that, this length of OB is equal to the length BC, and the length OC is double the length OB. Now, we also have a couple of extra points that we need to consider. One of the points is the point D, which is defined such that DC is parallel to AB and AD is perpendicular to AB. Now with the first condition, if we consider the line AB, AB is this line right here. So if the line DC is parallel to line AB, it means that the point D is such that if you draw the line DC, which is parallel to AB, which is going to be a line like this, then the point D is going to be somewhere on this line. Now furthermore, from the other condition that AD is perpendicular to AB, if we consider the line AB, which is this line, then the point D must be on the line that goes through A perpendicular to AB, since AD is perpendicular to AB. So due to that, if we just draw the line that is perpendicular to AB, which is like this, then the point D must be on this line. So therefore, from these two conditions, the point D must be on this line and this line at the same time. Now as we can see, there's one intersection of these two lines, and that's this point right here, which means that the point D must be this point right here. So we can now erase everything else. We don't need any of the other stuff. We can erase this part, and also this little part of this line up here, and this part of the line down here, and we can now label the point D as being the point that is right over here. So this is the point D. Now we also have another point to label, and that point is the point E, which is the intersection of the point of the lines AB and OD rather. So AB and OD, AB we've already drawn, and OD is the line from O to D, which is this line right here, meaning that considering the intersection of these two lines, which is this point right here, this point must be the point E. So therefore the point E is this intersection point right here. And with that, we have completed our diagram. So now we can start drawing relationships in all of these different points and lines that we can use to solve the question that we've asked. So first off, we know that DC is parallel to AB. Now if two vectors are parallel to each other, it means they're traveling the same direction. And due to that, one of the vectors must be a scalar multiple of the other vector. So in this case, we have the vector AB and the vector DC. So due to the fact, we can say, since the DC vector is given to be parallel to the AB vector, we can say that DC vector is going to be a scalar multiple of AB vector, which I'm going to write as DC vector being equal to lambda times AB vector, where lambda is a scalar, and we could also say lambda is an element of the real numbers. So now we have established the fact that since DC is parallel to AB, DC must be a scalar multiple of the vector AB. Now we can use this information in order to find the coordinates of the point D. To do that, what we need to do first is to consider the equations that we have here and consider how we can represent this in terms of the position vectors of the points D, C, A and B. Now to do this, I'm going to go up here. I'm going to define the position vector of the point C to be C vector and the point D to be D vector. The reason for this is because the position vector of the point A is given as A vector and the position vector of the point B is given as B vector. So to keep that pattern and for convenience, I'm going to say let the OC vector be equal to C vector and OD vector be equal to D vector, just for convenience. So now OD vector that I want up here is just the D vector that we have here. So now what I'm going to do is to convert this into the forms that are containing only unit vectors, only position vectors of the points A, B, C and D. To do that, I'm going to use the fact that if you have any point, let's say X, and another point Y, and you have the vector XY, this is going to be equal to the point X to another point, let's say Z's vector, plus that point Z to the last point, which is Y's vector. So we have X to Y's vector being equal to X to Z's vector plus Z to Y's vector. Now we're going to use this in this particular situation to write the DC vector as the D to origin vector plus the origin to C vector. And similarly, we're going to have that being equal to lambda times, and we're going to take the AB vector and write it as the A to O vector plus the O to B vector. Now with this, we know the O to C vector and we know the O to B vector, since those are just the position vectors of the C point and the B point. But the DO vector and AO vector we don't directly know, but we know that D to O vector is the negative O to D vector, and then we have plus OC vector, and similarly on the other side we have lambda times, and we know that AO vector is just negative OA vector and plus OB vector. Now to this we can substitute the fact that OD vector is what you call D vector, so we have minus D vector and plus C vector equal to lambda times, and over here minus OA vector is minus A vector and OB vector is B vector. So we have this. Now additional to this, we know that OC vector is double of OB vector. So since OC vector is double of OB vector, we can say since OC vector is equal to double of OB vector, this implies that the C vector that we had is equal to double of the B vector, which we can substitute into here and say that finally minus D vector plus 2B vector is equal to lambda times minus A vector plus B vector. Now finally, we can rearrange this vector equation in order to get D vector by taking D vector to this side and this thing to the other side, which we will, if we do, we are going to get D vector equals, on the other side we're going to have 2B vector, so 2B vector, and then if I take this thing to the other side, what I can do is to flip the signs of this thing and write it as plus lambda times A vector minus B vector. So there we go, D vector is equal to all of this. Now I can actually simplify this down, but I'm not going to do that for now. I'm going to keep this as equation number 1. I could simplify it, but for now I'm going to leave it as D vector equals 2B vector plus lambda times A vector minus B vector. Now if I can find another equation for D vector in terms of some things and lambda, then I can solve for lambda. So to do that, what I'm going to do is to use the other condition that we know for the D point, which is that the AD vector is perpendicular to the AB vector. So I'm going to draw that over here in the diagram as a 90-degree angle, and I can use the fact that the AB vector is perpendicular to AD vector to derive another equation for the point D or the vector OD. So what I'm going to do is to take that fact that AB vector is perpendicular to AD vector, and what we know for two perpendicular vectors is that the dot product is equal to 0. So I'm going to say that the dot product of AB vector and AD vector is equal to 0. Now I know AB vector and AD vector in terms of simpler vectors. What I know is that AB vector is going to be equal the A to O vector plus the O to B vector. And we can see here the A to O vector is simply the A vector minus, and OB vector is simply the B vector. So therefore I can substitute for AB vector as B vector minus A vector. Now similarly for the A to D vector, AD is simply AO plus OD, and AO is minus A vector and OD is plus D vector. So due to that I can substitute for that as well as D vector minus A vector, and that is equal to 0. Now I'm going to call this equation number 2, and what I'm going to do next is to take equation number 1 and substitute it into equation number 2. So if I do that, I'm going to get B vector minus A vector dot product 2B vector plus lambda times A vector minus B vector minus A vector equals 0. Now to simplify this equation further, what I'm going to do is to substitute in the actual values of A vector and B vector. So as we know from the question, A vector is equal to minus I vector plus J vector, and B vector is equal to I vector plus 2J vector. So if I substitute those two in, we're going to get on the left hand side in the first bracket, B vector minus A vector is going to become I vector plus 2J vector, and then minus A vector is going to become plus I vector minus J vector dot, on the right hand side 2B vector is going to become 2I vector plus 4J vector, and then plus lambda times A vector minus B vector, which is minus I vector plus J vector, and then minus I vector minus 2J vector, and close bracket, and minus A vector. A vector is going to be minus I vector plus J vector. So minus A vector is going to become plus I vector minus J vector. And that is all equal to 0. So now what we're going to do is to group all the I vector and J vector components together. And doing so, the left bracket becomes I vector plus I vector is 2I vector. 2J vector minus J vector is plus J vector. And on the right side, the right bracket becomes 2I vector plus I vector is 3I vector, and then inside we have another lambda times we have minus I and minus I minus 2I. So minus 2 lambda I. So minus 2 lambda I, and on the outside we have 3I, which means we have in total of I components 3 minus 2 lambda I vector, and in terms of J components on the outside we have 4J minus J, which is 3J, so we have 3 on the outside. Inside we have J minus 2J, which is going to become minus J, so we have minus J times lambda, which means in total we have plus 3 minus lambda J vector component, and that's all equal to 0. So now, since both of these vectors that we're dot producting together are in the I plus J form, we can just take the coefficient of the two I's, which is this component and this component here, multiply them together, and add to that the product of the two coefficients of the J's here and here. So therefore, the dot product here is going to become 2 times 3 minus 2 lambda plus, and then here is 1, so we have 1 times 3 minus lambda equals 0, and simplifying this down we have 2 times 3, which is 6, minus 4 lambda plus 3 minus lambda equals 0, which if we rearrange we can see lambda taken to one side we have 5 lambda equals 9, meaning that lambda is equal to 9 over 5. So now we found lambda equals 9 over 5. Now with this we can go back up and substitute equation number 1 in order to find the actual value of the D vector. So we can say from 1, D vector is equal to 2B vector, which is going to be 2 times 2 times I plus 2J, which is going to become 2I plus 4J, 2I vector plus 4J vector, and then plus lambda, which is plus 9 over 5 times A vector minus B vector, which as we know A vector minus B vector is going to become from, we can actually find it from here. So we have B vector minus A vector is 2I plus J, so therefore A vector minus B vector is going to become minus 2I minus J. So we have minus 2I vector minus J vector, and now if we simplify down we're going to get D vector equals 2I vector plus 9 over 5 times negative 2I vector, which is going to become minus, in total we have minus 18 here and plus 2 over 5, which is going to be 10, minus 18 minus 8 over 5 I vector, and then as for J vector component we have 4 and 9 over 5 times negative 1, so negative 9, and taking this to the top, we're going to have 20. So we have 20 minus 9, which is 11 over 5, so we have plus 11 over 5 j vector. And therefore the d vector is that, but what they wanted was OD vector. We know that OD vector is the same exact thing, but we'll write that as well. Instead of d vector, we'll write OD vector from O to D, and that's equal to minus 8 over 5i plus 11 over 5j, which is what they want in the question. And therefore, we have our answer. We have found the OD vector. Now, after finding the OD vector, they then asked us to let E be the point of intersection of AB and OD, and given that we have to show that AE is equal to 1/10 of AB. Now, looking at AB and AE, since all 3 points are collinear, since by definition E is the intersection of AB and OD, we can say that considering the AE vector and AB vector, AE vector is going to be a multiple of the AB vector, or scalar multiple we could say. So going down, we can say since AE vector is parallel to AB vector, we can say that AE vector must be equal to mu times AB vector, where mu is a scalar, and we can also say mu element of the real numbers. So now we've established the fact that since AE is parallel to AB, AE must be a multiple of AB, and that is actually what we want in the question. But what we need is to show that AE is equal to 1/10 of AB. So we need to show that basically mu is equal to 1/10. Now to do that, we can try to find other interesting relationship that we have here, and if we take a look, we will notice that if we consider these two lines DC and AB, DC and AB are parallel, and they divide OC into two equal components, this component and this component. Now, as you know, a theorem in geometry states that if you have something like this, we have two parallel lines and an external point, and from the external point you draw a line, let's say like this, and it goes through both of these parallel lines, then the two parallel lines will divide this line into two components, this component and this component, and if you use the same external point, then no matter where you cut through, the two components will have the same ratio. So here we can see at this particular instance, since the ratio is 1:1, meaning that OB to BC ratio is 1:1, we can say that the ratio anywhere else will also be equal to 1:1. Now here, if you take a look, you will notice that considering the OD vector here, the OD line is also passing through both of these parallel lines, and it divides into two pieces of OE and ED. Now since the ratio here is 1:1, we can also say that the ratio here is also going to be 1:1. So due to this, we can say that OE is equal to ED, and therefore OE plus ED is equal to 2OE, which is equal to OD. So due to that, if we go down, we can say, we have to of course describe this. So we can say something like since, and to describe the situation, we have to say something like CD vector parallel to AB vector, and they divide OC line into two equal line segments OB and BC. The same will be true for any other line that passes through the point O and cuts through both of these lines. So therefore, for the other line, which is OD will also be divided into two equal line segments, and the two relevant line segments in that above situation are OE and ED. So we can say therefore OE is equal to ED is equal to 1/2 of OD, since both of them added together are equal to OD. So we can actually use this later, and I'm going to call this equation number 4. I'm calling it equation number 4 because actually from up here, we could create another equation, equation number 3. So for equation number 3, I'm not going to call this equation number 3, but rather I'm going to convert this into vectors that are in terms of the position vectors of A, E, and B. And for that, I'm actually going to go up. I'm going to say, similar to how we defined OC and OD, I'm going to say let OE vector be equal to E. Now given this, if we go down, from what we have that AE vector is equal to mu times AB vector, which I can convert into saying that E vector minus A vector is equal to mu times B vector minus A vector. And now I'm going to call this equation number 3. So we can use equation number 3 and equation number 4 to derive something. Now considering 3 and 4, here we can see OE vector is equal to half of OD vector. And due to that, OE vector is going to be equal to 1/2 of the OD vector, which we just found to be equal to negative 8 over 5i plus 11 over 5j. So negative 8 over 5i plus 11 over 5j. Now it should be noted that just because the lengths are equal doesn't mean the vectors are also equal, but since OE and OD are in the same direction, these are equal. So you should be careful of that. In fact, I might want to say that OE vector and OD vector are in the same direction. Just to make it extra clear why I can directly say that OE vector is half of OD vector. So now we have this, which we can then substitute into this equation up here in order to solve for mu. So solving for mu, we can say from 3 and 4, if I substitute E vector into the above, I'm going to get E vector minus A vector, which is going to be half of this thing, which if I substitute, I'm going to get half of this thing, which is going to be minus 8 over 10i plus 11 over 10j minus A vector, which is going to be minus I plus j, which is going to be plus I minus j equal to mu times, and on the right side we're going to have B vector minus A vector, which is going to be I plus 2j minus I minus I minus j, which is going to be I vector plus 2j vector plus I vector minus j vector. So simplifying both of these down, on the left hand side we have negative 8 over 10 plus 1, which is going to be 10 over 10, which is going to become 2 over 10. So we have 2 over 10 I vector, and for the other part, the j part, we have 10 or 11 over 10 rather, and minus 10 over 10, which will become minus 1 over 10. So we have minus, or not minus, plus 1 over 10 j vector. That's going to be equal to mu times, and on the right side here we have 2i and 1j, so we have 2i vector plus j vector, and we can see here this must mean that 2 over 10 is equal to 2 mu, and also of course that 1 over 10 is equal to mu, since of course the coefficients of I in both of these and the coefficients of j in both of these must be the same. Now from the first equation we can see that mu is equal to 1 over 10, and that agrees with the second one, so therefore we can say therefore mu equals 1 over 10. So from mu equals 1 over 10, finally from equation number 3 we can say since mu equals 1 over 10, AE vector must equal 1 over 10 AB vector. And thus we have solved this question, and that's going to be the end of the question. So now finally, let's discuss the marks awarded for this question. So at the start of the question, when you take the fact that DC is parallel to AB and you use it to say that DC must be equal to lambda AB, you get 5 marks. When you then convert DC and AB into their vector forms in terms of only the position vectors of the points A, B, C, D, and you write it like this, you get 5 marks. Then, when you take the fact that OC is equal to 2OB to mean that C vector is equal to 2B vector, you substitute and you get this equation right here, you get 5 marks. After that, when you use the other fact that AB and AD are perpendicular to say that their dot product is equal to 0, you get 5 marks. And when you substitute into there and you get this equation, you get another 5 marks. When you then simplify this down to eventually get that lambda is equal to 9 over 5, you get 5 marks. And then when you reapply this back into equation number 1, substituting get you 5 marks, and getting the final answer of OD equals negative 8 over 5i plus 11 over 5j gets you another 5 marks. Now in the next part of the question, for E, when you say that since AE parallel to AB, we must have the case that AE is equal to mu AB, you get 5 marks. And then, when you use the geometrical fact that since CD and AB are parallel, they're going to divide OD into 2 equal components, and you say that OE is equal to ED is equal to half of OD, you get 5 marks. When you then use both of these facts together, you substitute one into the other and you get this equation right here, you get 5 marks. When you use that equation to get that mu is equal to 1 over 10, you get 5 marks. Or alternatively, if you use that and directly write that equation number 3 is going to give that AE vector is equal to 1/10 of AB vector, you get that 5 marks. And that is going to be all for this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.